Welcome back to CSS and JS episode number 4. Today we are dealing with a very simple feeling CSS selector, div space div. That's it, and it turns out it's recursive. And it turns out it's recursive. And it turns out it's recursive. And it turns out, okay, you get the point. It's infinite. That div space div will find every div inside of a div until it reaches the end of every tree, of every branch in your DOM tree. Right? Okay, it doesn't feel like it's that complex, right? It feels pretty simple. Well, we're going to rebuild that in JavaScript today. We are going to re-implement what that recursive selection is doing, and that will help us feel the strength of CSS, its succinctness, as well as how things that are very simple can become a little bit dangerous. It's not even dangerous. It's more like you might style something that you didn't expect to because it was a div inside of a div inside of a div. So anyway, let's jump right in. I have a kind of exciting little setup here. It's a little bit meta. It's kind of a play. If you look on the left, we have a little bit of recursion happening even in CSS. So we have recursive selectors. That's what we're working on today. But I've shown recursive typography. The padding on the left here is consistent because it's using a rem, and the font size is inconsistent. It's consistently getting smaller, and to be precise, 25% smaller as each div is nested inside of another div. So what I've created in our new example in our control is a div inside of a div inside of a div, the styles of which are padding left 1 rem and font size 0.75 em. And that gives us a recursive sort of look. We have like a steady just application of like a cascade, but we have recursion in font size. So anyway, I thought that was kind of meta and very fun. And if I pop back over to our code, we can begin doing what we always do. So our task today is to make this box on the right look like the one on the left. And I'm ready to go. And I'm just going to get started here. We always start with a little bit of pseudocode, a little pseudocode. Is that like, imitation crab is pseudocode? I don't know. Anyway, so we're going to take our little base set of nodes, and we're going to say we need all the children of these nodes, every single one of them, because then we're going to call our filter function, by attribute, and making sure that the node name is a div. Look, this is looking like CoffeeScript, and then we'll save for each of those apply style, right? Because that's what our CSS selector over here is saying. Control, find every div inside of a div inside of a div inside of a div of this control, all the divs forever, and that's what we've written here. We've got a base node, we need all of the children, and then we need to find all of the children that are div, and then we'll apply some styles. Let's get started. We have already created a direct descendants function in our utils over here, and now we need a total descendants function. So that's the one that we're building today. I'm calling this a recursive reducer because the way that we're going to author this is as a reducer function, which means it's going to take 2 parameters, instead of some of the other ones that we have over here, which only seem to take 1 node. And that recursive reducer is going to call itself. So it's a reducer in its shape, and then it's recursive because it's calling itself. And let's just do that. It turns out, at least to me, that this reads a lot like English. This is almost like how I would say the process that I want to happen. It's one of my favorite things about JavaScript is that whenever I can express myself in code really similar to the way that English would be, it makes me really happy. Maybe that's why I like to pseudocode. I don't know. But we're going to scroll down here, make sure we got that pulled up. Awesome. Our new function that we're writing, our recursive reducer, is total descendants. And a reducer takes 2 parameters. The first parameter is the aggregator. So I like to call these a seed or a vessel or a bag. It's like you have to hand a reducer something empty so that when it goes through each of the items, there's something to put the new items into, because that's ultimately what you get back, is you're going to get back that bag. You're going to get back the vessel, not each item. Okay, so what is our vessel called? We're going to call that total because that's what we're interested in here. And we're looking at children because we're looking at all children until we can have a total of all children. Great. So the way that this is going to get called is just like a normal reducer, and I will write that up here. So we're going to have experiments dot reduce, and we're going to call total descendants and pass in an empty vessel. Now this is a little trippy unless you're really comfy with reducers. If you're not comfy with a reducer, there's something backwards happening here. Notice that the second parameter that I pass here is actually the one that we get first in our function. And it's a little bit trippy because we didn't write this function here. We passed it the function reference. Notice that we're not, this is just like our other refactor. We're not invoking these. We're passing the reference to the function for it to be invoked later with parameters. And in this case, this function will get invoked with the parameters of a normal reducer, passing in the total, passing in the current child that's coming from the experiments, and that will kick off our flow here. And so if we are kicked off, our questions that we want to know are, okay, I'm crawling all of the children forever. What's the first question you ask? And you're saying, okay, so here comes a child. Well, hi child, I'm collecting things just like you, and I need to know, do you have any children? Because if you have children, that's pretty much my next step, is to go ask your children if they have any children, and then ask those children if they have any children. And I'm just going to keep gathering children forever. So my first question was, hey child, do you have any children? Is there length in your child array? If there is, then I want to go through each one of those children and call a reducer on them, just like my parent did over here, the experiments. And I'm going to pass into that reducer total descendants again. So here's the recursive part. So I have a reducer calling itself as a reducer. Now the vessel that we're passing in, this is the second call that we're making. We don't need a new vessel. What we need to do is take the one that we were given and pass it down to this recursive call, because what we want to do is take that same vessel, distribute it out amongst all the different branches, and come back with one vessel that's been totaled. So what we're going to do here is we're going to take all the items that are currently in the total array and expand those into a new array, as well as the child.children. So essentially what we're doing is we're saying, hey child, do you have children? You do? Cool. Call me again for each one of your children, but I'm going to pass into your siblings as well, or your children in there, so that they can be appended into that set. Right? So this is where we're building ourselves into that recursive total. This concludes the part of the question where it says, hey child, do you have any children? Because if you have children, we're going to crawl. If you don't have children, we're going to bail. And so that's what we're going to do next in this function, is we're going to say, okay, well then just return total. Because if you don't have any children, then I've already got what I needed. And I'm going to go back up, and then I'm going to ask those children, do they have children? And I'm going to keep until I've unwound myself back up into a single total. So we'll continue to drill into children, appending them into our vessel until we've reached no more children, and then we're going to return the vessel. And that vessel gets returned and built upon back up the chain. Kind of cool. And here we are, we're using it right here. And let's just set a debugger. Let me save all this work. Pop over here, Command Option I to launch these tools. I'll hit refresh so we get our debugger statement. Boom! Excellent. Pop back into the console. Okay, so we've got experiments.reduce. Oh, look, this is already written right here. That's cheating. It's not cheating when we know exactly what we're getting, right? But let's do this. Let's get rid of that. And we can see our work. We can see that if we go through each experiment and we call our reducer and we pass an empty vessel, we get back all of the children. And notice it doesn't know whether or not it's a div inside of a div inside of a div, or if it's an H2 or what type of node it is. It just is a crawler. It's a function that will return total descendants. That's excellent. That's exactly what I want. Because our next part is where we're going to filter. And we're going to filter by attribute, by node name, and we want to know if it's a div or not. Boop. And now our array has gone from something that had H2s in it to exclusively all of the divs. And there they are. And that means we can come back here. I can even grab this code because it's working great. Get rid of my debugger. Hit enter. I'm even going to get rid of the pseudocode. Paste that right here. Format it a little bit. Steal the for each assigned style that's right here. And write some CSS. So if I pop over to my control, I need to do padding left 1 rem. Excellent. Not a dot. Well, how about a comma? And font size at 0.75 em. Trailing comma. Back over here. get rid of that, pop out of my breakpoint by going back to sources, hitting the plus right here, reloading, and we are done. Wow. Okay, so this has been quite the adventure. This little thing to write, this recursive reducer, was really complex to initially get my mind around, but as soon as I had it written succinctly, I felt like it worked, and I felt like it worked in a way that fit the rest of the mantra of the series, and I feel pretty good about it. I like how we are creating this sort of like language as well, where we have this total descendants, direct descendants. We have these, we now have these functions that represent the way that we talk about our CSS. And the way and those functions are interesting because they tell us how those selectors are working. When normally when we talk about CSS, we just describe what we want. So we tackled a really hard computer science problem today with one function, and we reused all of our previous patterns that we had. We were able to take a complex selector and reduce it with a reducer. That's just fun to say out loud. I hope you enjoyed this episode. It's laying the groundwork for us to do much more complex stuff, and I think we're going to get into a scenario in the next few episodes where we're going to start to compose more of our functions together, and we can learn more about the power of CSS and its flexibility as we struggle to represent that same flexibility in JavaScript. Thanks for watching these videos. I hope you enjoyed episode number 4, and get excited for number 5. Take care, y'all. Stay cool.